Assalamu alaikum and greetings to our dear lecturer and also all the viewers. We are Group 1 from Section 2. We'll be presenting our project for discrete structure called Connections of Peninsular Malaysia's main city between each region. Kruskal algorithm for minimum spanning tree. Our group member consisting of Khalif Aziz, Arif Aiman, Wan Amirul, Said Amirul, and also Aiman Firdaus.
Okay, so for our introduction, graph theory is frequently used to illustrate a variety of network design related issues, including those involving computer networks, telephone cable networks, electrical system, and road networks. The upcoming study aims to clarify several terms and provide a thorough example of the graph while delving into a basic definition of graphs. The idea of spanning trees is introduced by graph theory in order to find the paths that connect every node in a particular network. The objective of the MST problem is to minimize the total of the weights assigned it to an edges by identifying the spanning tree within the edge weighted undirected graph. The MSC affects the effective design of computer networks, phone cable networks, power grids, and road networks, both directly and indirectly.
So for the background of studies, Peninsular Malaysia 12 main city are connected by an effective road network built using Kruskal algorithm. The goal of Kruskal algorithm is to increase efficiency and connectivity by identifying the most efficient route between city. It was selected due to its efficiency in optimizing large network such as city road infrastructure. The work emphasized the practical application of Kruskal algorithm in urban planning by bridging theoretical algorithmic concept with real-world challenge. Understanding the algorithm efficacy in resolving practical issue requires evaluating its complexity. The resilience and effectiveness of urban road infrastructure in modern city planning could be greatly increased by using Kruskal algorithm to create a minimal spanning tree.
Okay, for related literature, the two main algorithm for MST, Kruskal, and Prims. So what we have found is that Kruskal is to find shorter overall distance, but may be slower with many vertices. And for Prim, we found it to be efficient for finding specific short paths and optimizing local transport routes. The choices depends on network features, desired outcome, and number of vertices. Kruskal is better for shorter overall distances in large networks, Prim for optimizing specific paths in smaller networks.
Now, moving on to methodology, the one algorithm that we use within the greedy algorithm scope is called Kruskal algorithm. So, first, it was introduced by Joseph Kruskal in 1956. So, this algorithm, his algorithm that he created, efficiently construct the minimum spanning tree, or also known as MST. So, how it can make MST is by carefully ordering edges based on their weight. So they basically go through every edges and see if the edges is heavy or light, depends on their weight. So the process actually involved in systematically selecting the edges, ensuring no cycles are formed because it is a path, and lastly greedily adding the minimum weight path to the growing spanning tree. Now, moving on to step-by-step progression for the Kruskal algorithm. As you can see here, these are the algorithm for the Kruskal graph. So what this algorithm does is actually maintaining a forest of disjoint sets, initially consisting of individual nodes. So first, it goes through the edge of the graph in ascending order of the weight, adding the edge to the minimum spanning tree if it connects two different sets. This is to avoid cycles because it is a path. Keep that in mind. So the algorithm then merge the sets of the connected nodes or vertices, and then this process will continue until all the nodes are part of a single set, resulting edge form for the minimum spanning tree.
So, for our result and discussion in this project, we will talk about our output, our findings, and discuss about the problem that we have found in our research. So, this the diagram shows the graph of the 12 node as main cities in Peninsular Malaysia, which is we have Kuala Lumpur, Pulau Pinang, Johor Bahru, Ipoh, Bandar Melaka, Kuantan, Kuala Terengganu, Shah Alam, Kota Baru, Seremban, Kanga, and Austa. So this the 12 node as main cities that we use in our Kruskal algorithm for our minimum spanning tree. MST. So, without further ado, let's start our system demonstration for our project. So, for our project, our system demonstration, as we can see here, we are using Python as our programming language for our project. And as we can break down the codes here, so we will create a graphical um, output or graph in Python that will shows our MST or minimum spanning tree based on our Kruskal algorithm. So as we can see here, there are 12 cities in our project, which is Kuala Lumpur, Penang, Johor Bahru, Ipoh, Bandar Melaka, Kuantan, Shah Alam, Kota Baru, Kanga, Alustar, Seremban, and Kuala Terengganu. So this is our 12 nodes in our project. So as we can see here, these are the connections. We have 16 connections, and they all have their respective weight in the connections or the edges. So as we can see here, there are nodes that uh, we adding. So we're adding nodes by using this code, and we're adding edges with weights. We're using for loop, and we're computing the minimum spanning tree, and we create the new graph and draw the minimum spanning tree. So we draw the edges and we choose our style or color the edges to pop up and to for the user to visualize the MST for our project. So uh, as you can see here also, they are drawing a non-MST edge. So the non-MST edge will be gray. The edges will be gray, and the red one is the minimum spanning tree edges. So we add in the edge labels, which are our main cities in the peninsula of Malaysia. So we run the code. So wait for the code to run, and yes, here we have the minimum spanning tree for using Kruskal algorithm for the main cities in Peninsular Malaysia. So as we can see here, uh, it will be visualize the code the same as our report generates. It is the same diagram as our report. So the diagram can change if you will run it again, but it will still shows the MST for our Kruskal algorithm and our main cities. So we can run many times and we can see different type of diagram, but the same output. So that's all from me for our system demonstration.
So, lastly, for the conclusion, the Kruskal algorithm is strategically employed to design an efficient road network connecting major cities in Peninsular Malaysia. The primary objective is to create an interconnected web prioritizing minimal travel distance, enhancing transportation across the region. Through meticulous analysis and validation with a comprehensive dataset, Kruskal algorithm prove its efficiency in optimizing travel distance across diverse urban centers. So the algorithm computational brilliance is evident in selecting optimal routes, revolutionizing intercity travel within the Malaysia Peninsula. The result underscore a pioneering effort to establish a harmonious, connected road network, evaluating travel experience and redefine connectivity in the region. So that's all from us. Thank you.
That is all for our group project presentation, and I would love to thank you for your attention to our project presentation, and best regards to Madam Azwan Izzah binti Poharan. So, thank you and Assalamualaikum.